So the next presentation is by Paul Daniels. It's going to be on the FAS survey of the effect of satellite constellations on UK amateur astronomy. Over to you. I'll give you a 5-minute warning.
Okay, thanks. Turn the brightness up. Start my own timer.
Okay, it's on the screen now.
Okay, thank you. I have to say I felt a little old when I first got notice of this symposium. The only other IAUS symposium I've spoken at was IAUS Symposium 90, which was over 40 years ago, solid particles in the solar system. Thank you to the IAU for the invitation and some travel grant. Thank you also to the FAS, who I said to them, I'd like to organise this survey. And they said, oh, yes, great, Paul. And it was more cheerleading encouragement. But they also gave me a travel grant, which was very nice. Particular thanks to Martin Baker, who is the FAS webmaster, for helping to develop the survey form. And Meredith Rawls, Olive Hainer, and Federico De Bruno for advice on some of the questions and encouragement to go global with the survey. So the title in fact, was for UK amateur astronomy, but it is now more global than that. And thank you all to all of those who helped to spread the word about the survey, particularly Roger Davis of the EAS and fruitful suggestion from Connie Walker to approach the Night Sky Network, and the word went out and people responded to the survey. So, as introduction, the FAS is a federation of 200 member societies thereabouts, and so indirectly we represent in the UK about 12,000 amateur astronomers. So the survey was based originally on the SATCON2 survey and was originally, as I say, for UK amateurs alone, but expanding it meant that I got about 25% or so more responses than I perhaps otherwise would have done. Survey was launched on the 26th of August, and we said to people, we're going to close this down midnight on the 22nd. It's nice if people have got a deadline to go to. And certainly there were some submissions that were 5 minutes before midnight on the 22nd. In practice, we collected responses for a little longer than that until we actually closed the form, and we got another 5 responses after the deadline. So we got 547 responses altogether, and in an entirely non-competitive vein, that's 7 more than the previous SATCON2 satellite got. So how do we do this? We used JotForm. JotForm provides you with a builder so that you can build your forms. All of the features are available. There is a free version that you can use that has all of the features. It's limited in how many forms you can have, how much storage you can have, how many submissions you can receive, but it's good for being able to develop your form before you finally publish it. And then you can move to one of the paid subscriptions. It's not cheap, it's about $34 a month, I think, for the most basic version. And from there, we published this, and our data was submitted to our FAS Google Drive. And I think you can choose where you want the output from the survey to go to. So JotForm is feeding data into this repository, and I did this by creating an Excel workbook, excuse me, with a link up to that cloud repository, so that I could update the data in the workbook. I could develop the analysis in the workbook, even as the data was coming in before the survey was closed. So it led eventually to 12 spreadsheets, 1 graph, 3 heat maps, and 112 pie charts. So once I have done some tidy up work, removing, for example, names and addresses, because GDPR doesn't allow me to pass that out. And I'll add some comments onto the VBA. There aren't any at the moment. I'll release the data and the analysis file and the survey questions up onto Slack so anybody can have a go and look at the data and the analysis and see what I did. So the questions that were there on the survey were some single choice questions. So you got multiple choices of which you could choose one, some multiple choices of which you could choose more than one, and there were often other options as well, which then opened up a text box to provide a text option as well. So it divided up into three fairly clear latitude ranges. The first range I've called range A here, which is for mostly the UK, I would say, and Northern Europe and Canada. But since this went out to FAS members, most of them are going to be from the UK. Range B, I would guess, is the US and Southern Europe. And then we have range C, which is basically those that responded from the Southern Hemisphere. We didn't ask which country people were coming from. We just asked for their latitude. So this seemed a fairly natural way of breaking the data up. So one of the questions, and because of the fact that I have analysed this versus latitude, it means that there are a lot of pie charts, and so I'm going to be cherry picking some of the answers that I got. So one of the first ones was the instruments that were used, and you can see here that it's fairly consistent across the range. There isn't a great deal of difference between the different latitudes there, so that's nice to see because it perhaps says things about the data later on. You can see that quite a lot of people do naked eye observation, and you can see also that the rest of them, the two largest pie slices after that, were the medium-sized binoculars and the medium-sized telescopes. In the other boxes that people filled in, they said, oh yes, we have H-alpha telescopes like the Coronado PST, meteor cameras, and some people also using photometers for variable star work. We did ask about radio, those who did radio, and we got quite a lot of replies from that as to the equipment they had. The jot form's very good in that you can actually say, if this box is not ticked, then don't show this page. So at this point here, if people didn't say, oh, we do radio astronomy, then they didn't get to see the radio astronomy questions later on. So it helped to keep the analysis short and also reduced the form-filling fatigue for people doing the survey. Similarly, there were some responses from spectroscopy. Now, even though I'm only showing you some of the data here, there is a lot more in the Excel workbook, which, as I say, will be available to anyone who would like it. So, naked eye observations. You can see here that there's quite a lot of people here who have said zero or minimal impact to their naked eye observation. You can see that there are more moderates for the significant or severe responses, fewer significant or severe responses for range B. There is some difference there between the latitude, but overall 50% of people regarded as zero or minimal change. And I suspect this is because a lot of the people who do naked eye astronomy are relatively casual observers, and there's nothing detailed there that worries them too much. For the same question on binocular telescopes, you can see here that there is now a greater proportion of people who are concerned about the data. And you can see here now that more than 90% regard the intrusion as non-zero, and about 2/3 or so regard it as moderate or worse, and 1 in 6 regarding it as significant or severe. So people with binoculars and telescopes reasonably are more concerned than before. And then we have, for people doing imaging, and now this has grown much more, the slice that represents significant or severe has grown, and moderate has grown. And again, understandably, those who are doing imaging with longer exposures are finding it much more of a problem. So this is not at all surprising. In fact, if I flick backwards fairly quickly, you can see how, and then forwards again to binoculars, and you can see how the pie slices were changed. It took me some time to line those up carefully so I could do that.
5 minutes.
Okay, thank you. So with imaging, what kinds of imaging are people doing? Now I realise that one of the problems with this, of course, is that it is very skewed by the fact that some people might prefer to image galaxies rather than comets, or prefer to do solar imaging rather than meteors or constellations. So it's skewed very much by what people prefer to do rather than how much it has affected them in what they're doing. But there's still some useful results that come out here. If you categorize it, as I have done in the table, where you've got the extended fuzzy objects on the top there, you can see that these people are more affected than the others because they have longer exposures and wider fields. Those who are doing panoramas and constellations, star trails and meteor showers, they may also have long exposures, but the duration of the satellite trail going through it is probably fairly short compared to the length of their exposure. Or else the exposure is fairly short because it's a constellation, for example, that they're taking pictures of. And then you've got the people who are doing planetary work or solar lunar work, where they're taking very short exposures, and the objects are fairly small and well defined, and therefore they're much less likely to be affected. And so you can see from the pie charts that, again, this seems to naturally divide up the groups of observations that are being affected. So the question was asked, and again the question was asked for other categories as well, but no time to show all of them. For those doing imaging, how much do they think that it has changed in the last 5 years? I got a lot of responses from people saying, well, I only started imaging 3 years ago, or I only started imaging, or I'm new to it, only started this year, but I'm hoping that the ones that did respond with a number actually are useful. You can see that the Northern Hemisphere observers thought that the effects were worse than those in the Southern Hemisphere. And I have to say that the Southern Hemisphere observers, I think, are mostly North Sydney Astronomical Society, judging by one or two of the emails that I received. Maybe there is also some skew there because the southern contingent is mostly one particular group of people. Mitigation techniques that are being used. The top row here shows the mitigation techniques that people are using, and the bottom row here of pie chart shows how effective they thought that their mitigation effects were. You can see that by far and away the reddish-brown large slice shows that over half of them are using image stacking, where they're throwing away the images that have a satellite trail on and then just stacking the rest. Or some of them are using image processing to try and remove the trails. Maybe they're using a combination of both, where they're doing image processing on the damaged images and then integrating those in with stacking in the hope that the improved images have less of an impact on a larger stacked set. Either way, it also shows from the bottom row, where you can see the very large green slice, that for the most part people thought that these processes they're using here are effective, and about 3/4 of them thought that the techniques they're using are effective.
1 minute.
So it'll be very good to see what the effect is when there are better tools available for them to use, and it suggests maybe that there should be quite a concerted campaign to introduce the new tools that are coming along to the amateur community. So a question was, at what time of night were people mostly affected? And there are no huge problems here. People mostly were affected at the start of the night and around midnight, and I suspect, again, this is skewed data in the sense that a lot of astronomers, a lot of amateurs also go to bed at perhaps 2 in the morning rather than stay up until 3, 4 and the first fingers of dawn start to show. So maybe that's a certain skew on this, but again, not so much in the sunset and sunrise times. This heat map shows where people saw the parts of the sky most affected. Just to point out that the range C at the bottom, I have rotated the compass points so that you can do a direct comparison between the 3 heat maps, and you can see that those in the northern hemisphere, range A and range C are most similar. Those in the US and southern Europe seem to have more of a problem to the east and the west rather than northeast, northwest, southeast, southwest.
Can you wrap up shortly?
Yep, this is my last slide, I think. Is this 13? I think it's my last slide. And so this was how aware were people of resources that were available. This was a little disappointing because it showed that with the large blue slice on the top row there, a lot of people saying they weren't aware of any resources that were available to them to help them mitigate the problems and carry on with their astronomy. So this is maybe something that needs to be addressed in going out to the amateurs and showing them how they can work around this and asking for their help. Of particular concern also, and maybe it's down to the small numbers in range C, but it appears that no one in the southern hemisphere that responded knew about IAUS CPS. So maybe there's some campaign work there to be done. The bottom row there was a question of how aware were they of the number of proposed launches, and many of them said, again from the large green slice there, many of them were saying, well, we knew it was going to happen, but we didn't realize it was this bad. And typically about 3/4 of them were saying that they are aware or fully aware, or that they were aware, but it's worse than they thought. Okay, thank you.